Good morning, students. Today we are going to see the GCD of the polynomials, 10th standard portions. By using Euclid's divisions algorithm, we can find the GCD of two numbers. For example, we take the numbers 34 and 76. How can we find the GCD of these two numbers by using Euclidean division algorithms? Take the big number 76, divide this number by the small. In 76, 1 times 34. Find the remainder 6 minus 4, 2, 7 minus 3, 4. Now, the remainder is now 42. It is more than the divisor. So, 2 times. Now, 2 times means 2 into 34. 68. Now, find the remainder. 16. 8 is the remainder. Now, divide this 34 by 8. In 34, how many 8? 4 8s are 32. Balance 2. Divide this 8 by 2. 4 times 4 2s are 8. The remainder is 0. Therefore, the GCD of 34, 76 equal to 2. This you know very well. The same method only applicable for the polynomial also. We are going to follow the same procedure for the polynomial also. As the example, take the first sum in exercise 3.3. Find the GCD of x power 4 plus 3x square, 3x cube minus x minus 3 and x cube plus x square minus 5x plus 3. See, we are going to find the GCD of these two polynomials. Now, this is the fourth degree polynomial and this is the third degree polynomial. So, we can divide the more degree polynomial by the fewer degree polynomials. That is, we divided this first one by second. X power 4, 3x cube, there is no square term, so take 0 x square minus x minus 3. Take this polynomial x cube plus x square minus 5x plus 3. Now, divide the first term by the first term. X power 4 divided by x cube. That is x. Now multiply the polynomial by the x. X power 4 plus x cube minus 5x square plus 3x. For the subtraction, change all the sign of the polynomial. Minus, this also minus, plus, minus. Now this x power 4 cancel. 3x cube minus x cube. So 2x cube. 0x square plus 5x square. So 5x square. Minus x minus 3x. So minus 4x minus 3. Now, here this x cube and here 2x cube. Divide this first term because the remainder, the degree of the remainder also equal. So, divide the first term by the first term. 2x cube divided by x cube, that is 2. So, plus 2. Now, multiply this by 2. 2x cube plus 2x square minus 10x plus 6. For the subtraction, change the sign. Now the first term cancel. Here 5x square minus 2x square. So 3x square minus 4x plus 10x. So plus 6x minus 3 minus 6 minus 9. Here all the coefficient is divided by 3. So we may take this as 3 into x square 2x minus 3. Now take the divisor here. X cube plus x square minus 5x plus 3. Divide this by the polynomial. Here we have x cube and here first term x square. So divide the first term by the first term x. Multiply x cube 2x square minus 3x. For the subtraction, change the sign. We get first term cancel, second term minus x square minus 2x plus 3. Again, here the first term x square minus x square. So divide minus 1. So minus x square minus 2x plus 3. For the subtraction, change the sign. All the terms are cancelled, so we get to 0. So the GCD of the given polynomial is this divises the quotients. Because this quotient only leaves the remainder as 0, so this is the GCD. So GCD equal to x square plus 2x minus 3. See, once again I explain this. Here This is the fourth degree polynomial and this is the third degree polynomial. So divide this fourth degree polynomial by the third degree polynomial. When write the polynomials, we write all the terms. Sometimes some terms may be missing. In this, particularly in this polynomial, the square term is missing, so I take 0x square. Okay. Now divide this first term by the first term. Here x, multiply this by x, and subtract. We get this. In the remainder, the degree of this remainder and this degree also equal. So again, divide the first term by the first term. We get 2 plus 2. Multiply everything by plus 2. Then subtract. For the subtraction, change the sign and we get 3x square plus 6x minus 9. Here, in this polynomial, all the coefficients are divided by 3. So divide it. When we divide by 3, we get x square plus 2x minus 3. Now, take this here. Then by use the divisions, if we do it, we get a 0. So, when we divide by this polynomial, we get the 0. So, this is the GCD of our polynomials. These two polynomials, this is the GCD. In the same way, you can try the other problems. When we see the second problems in this exercises, the first three problems are the polynomials are monomials, that is the single terms polynomials. For the single terms polynomial, how can we find the LCM or GCD? For LCM, the highest degree of all the variables, we may take like this. LCM is the highest degree of all the variables. That is, for example, LCM of 4x square y, comma 8x cube y square. See, the LCM of 4 and 8, we know 8. Now, x is one variable in this term, which is the more degree. Here, x square, here, x cube. So, this x cube is more degree. So, x cube. Next, here y and y square. So, 2 is more degree. So, y square. So, the LCM of the polynomial is 8x cube into y square. The same way, you can do the other sums also. As the another example, I take the fourth problem, the same fourth. P square minus 3p plus 2 and p square minus 4. We can factorize this as p minus 1, p minus 2. You know the procedure for the factorizations. And this factorizes P plus 2 P minus 2. Now LCM. LCM is the more power of all the terms. Here P minus 1 is one term. So P minus 1. Next P minus 2 is another term. Here one P minus 2 and here one P minus 2. But in both the polynomial, the power is 1, the degree is 1. So we take 1 P minus 2. If the degree is different, we take the more degree. But here the degree is same. Here 1 and here also 1. So we take P minus 2. Next P plus 2. Here there is no P plus 2. So this is the more degree term. So P plus 2. So the LCM is P minus 1, P minus 2 into P plus 2. The same way you can do the other problems. Okay, students.